Hey everybody, hope everyone is still hanging in there. This is a quick little video to kind of start the week. I thought this would be good to do right before you take the 4.2 quiz. I'm going to do 6 examples here. Get out of there. God. Anyway, I'm going to do 6 quick examples that should, set you up for success on the quiz. Please keep in mind that this graphing stuff is really important, and it's like one of the core things in all of like algebra. And so if you think about things like the Keystone exam, the SATs, absolutely you got to be solid with kind of knowing this. So these are 6 problems that I'm essentially going to graph, and I'm going to be kind of sketching my own plane because I know how most of you guys probably don't have a printer, so I'll just kind of model what you can pretty much do on your own little scrap paper. Anyway, let's get started. Number 1, when we are graphing these equations, what we are currently emphasizing big time is that oftentimes you will be given an equation that is in this form, that is written exactly like that. When you have an equation written exactly like that, that is very good news. Okay? Because when you have an equation like this, you can look at this and go, okay, this is written as y equals mx plus b. Now our m, and this is why it's really good news, our m is going to be the slope of our line that we're going to graph, and our b value is the y-intercept. If you can remember those details, you're in great shape. So here, our m value is going to be 3/2. That's our slope. And our b value is going to be -1, which again is our y-intercept. And knowing those two things, we can absolutely sketch a little graph of our line. So I mean, maybe like 1, 2, 3, I don't know. Just trying to get, like, you don't need to be the best artist in the world here, but I mean, just a little sort of mini plane. So remember, this -1 is our b value, which means it's our y-intercept. It's where our line is going to intercept the y-axis. This is our y-axis. So here's what we do. We begin with b. We go to -1 on the y-axis and we put a dot. Then we move with our m. The slope of our line is 3/2. Remember, slope is rise over run. So we're going to rise +3 and run +2 from that dot. So from this dot we go up 1, 2, 3, and then we go over 1, 2, and we can put another dot right there. So up 3, 1, 2, 3, over 2, and there would be our line. Number 2, same thing. This is written as y equals mx plus b. So our m is -2 and our b value is 4. sketch a neat little plane here. And remember, this is our y-intercept. You don't have to say this, but you might as well say 0, 4. Like saying that b equals 4 or that your y-intercept is 4, you might as well say the full coordinates are 0, 4 because you're just going on your y-axis to 4. All right? And now we have a slope of -2. Now remember, slope is, fully defined as a fraction. So sometimes in situations like this, you'll have to take your slope of -2 and make it into a full fraction. And you can always do that by putting it over 1. See, in number 1, we already had a fraction, rise over run. But in situations like this, when we just know that the slope is -2, you have to put it over 1 so that you have a rise over a run. And so we are at our y-intercept of 4, and having a -2 rise, that means we're going to go down 2, and then a +1 means we're going to go to the right. So we're going to go down 1, 2, and then to the right 1, and there's the quick little sketch of our line. Number 3. Okay, and I'm doing 6 examples because I'm trying to throw all the different, curveballs that could be thrown at you. You know what I mean? I'm trying to prepare you for every little plot twist that could trip you up. Like in number 3, here's the plot twist. It's pretty obvious that our b value is -3 because y equals mx plus b, so our b would be -3. But what's our m? Remember how m is in front of the x, mx? What number is in front of the x? Wouldn't it be 1? I mean, it's invisible, but it's 1, right? And once again, m is our slope, so it's best as a fraction. So we just put it over 1. 1 over 1 is our slope, okay? And we can go ahead and sketch our line. So again, we always begin with b, which is the y-intercept on the y-axis. So here would be -3 on the y-axis, and then we use our rise over run slope. So our rise would be +1, and our run would be +1. Remember, rise over run, +1 over +1. And so that would be that. Number 4, what plot twist awaits us here? Well, once again, this is absolutely in the form y equals mx plus b. So here, our m, I hope it's fairly obvious, is -1/2, because remember, m is what's in front of the x, y equals mx. But where is the b? There's your plot twist right there. What's b equal? Y equals -1/2 x plus, I guess it's 0. Well, I know it's 0. So that's how you do examples like this. When there literally is no plus or minus whatever over here, that means it's in a way it's +0. So b is 0. That's allowed. I mean, you can have a y-intercept of 0, right? Where is your, on your y-axis, where's 0? Wouldn't it be literally right there? Yes, it would. And so there's our y-intercept of 0. Now we move with m. Now, make sure you are aware of how this works. A negative slope, this means you would have a -1 over a positive 2. That negative I'm going to put with the 1, and the 2 is positive, okay? So it's negative 1 rise over a positive 2, which means we're going down 1 and to the right 2. Negative 1 for our rise, positive 2 for our run, so down 1, right 2. And there's that line. Remember, a negative slope means the line should be downhill, and a positive slope means the line should be uphill. Last couple, okay? The really special ones. This is where we were kind of getting into like 4.2b, or at least in 4.2b I tried to like really emphasize these special ones, okay? What makes these special? Well, this equation only has a y. All these other examples had both a y variable and an x variable. But when you have a linear equation that's supposed to graph as a line and you only have a y variable, that means your line is going to be horizontal. So here's what you do. You literally go to y equals negative 2. So on the y-axis we go to negative 2. And that's where we draw our horizontal line. Okay. So equations like this would result in a horizontal line, and your slope for any horizontal line would equal 0. And that's just the bottom line. Now, when you have an equation that only has an x and your equation is written just like that, that means your line is going to be vertical whenever there's only an x. So, similarly, you literally go to x equals 3. So on the x-axis, you go to positive 3. You can put a dot for all I care. I mean, it's fine. And that's where you draw your vertical line every time. So for all these, that's what you do. It's going to be vertical. And for any vertical line in the world, your slope is going to be undefined. Vertical lines, in other words, there is no slope at all, or your slope doesn't exist. Can't write. Alright, and that's the quick summary of like pretty much every little situation, you know what I mean? Slopes that were already fractions, slopes that were negative, slopes that you had to make into a fraction by putting it over 1, you know, slopes of 1 and you don't even like see the 1, it's invisible. Equations like this where your b value is 0, and then, you know, lines that are horizontal and lines that are vertical. And, you know, remember the neat little trick to remember that of J.Falk. Remember that neat little kind of trick to help you remember that? But anyway, that should prepare you quite nicely for the quiz.